today's first presenter is Miss Chan, and second presenter is Shu, and the third presenter is Ozaki. So let's start with presentation. Please start presentation.1人って14分でしたっけ？30分ですか。
Good morning, everyone. In this presentation, I will talk about the progress report since last month. So in last progress report last month, I talked about the work on understanding the channel's choice of public service delivery by using an agent-based approach. And then after that, I did some minor modification of the model based on the suggestions collected from the presentation, and also I work on the multi-objective optimization. I will talk this to you in detail later, and then talk some future work, the unfinished work. So previously, the model, by constructing a citizen-centered service provision model, we have a better understanding of the current situation of the e-government adoption for a particular kind of service. And also we find that for the increased awareness rate of e-government actually does not help improve the adoption rate of e-government, but the increased technical support does. But for different social groups, the effectiveness of the technical support is different. For those social groups who have used e-government more frequently, the increased technical support is more effective. And then after that, this is the previous work. And after that, I did some minor modification. The first modification is about the citizen action. This diagram, I changed it to flowchart based on Gwen's suggestion. So basically, this is the activity flow for citizen. Basically, they will compare the utility value for traditional counter and for the e-government. If the utility for traditional counter is smaller or equals to the utility of e-government, then they will choose traditional counter within the office hour. If it is out of the office hour, then the citizen will make no action. Then, based on Ichikawa-sensei's suggestion that we should allow the citizen have more choices, so I change it here. In every single run, if the utility of the traditional counter is not larger, but if it is out of the office hour, Then with probability PE, actually the citizen can choose e-government as other citizens. And with probability PTS, they can seek for the technical support. Otherwise, they will just calculate the time and effort for choosing e-government.
Excuse me.
Hi.
Can you return to the previous slide? Well, there's two, I think, is mistake in the flow chart. Is within office hour and with PD, because there should be yes and no direction line from the flow chart. So
You mean this one?
yes. So if it's not within the office hour, then what? No. I mean the no condition.
Yes, because in the original part, I didn't consider that situation. This is the new
Okay.
one.
Okay.
It's like this is the original one.
So if it's no, then
Yeah, in the original model.
what is the next process? It will
I
be
think we will make
to-
no action, then wait until the next simulation.
Okay, so no action is a kind of process that with no actions. So because fundamentally the flow chart which so it has yes, then it should have no, because it's a condition. And the right one too, which is one is yes and which is one is no. And until S, if S1 is more than an utility of S2, then no. The direction from no, there are two, So from here, we go to here or to here.
Yeah, that means with probability, this one, it will go here. If no probability, then it will go this way.
So in that case, so you can write like this. If is P smaller than PB
Yes.
TS, then you go to yes, no. So you can write like that, because in fact in every simulation too, if there is a probability variable, it will generate a random number, which is 0 and 1, and compare that random number to the probability, and if it is smaller than that, then it will be executed.
Sounds a bit changes later. But because while I draw this flow chart, I reference to some other papers. They just use this kind of diagram directly. So I think because they are published, so I think it's okay. Use.
Yeah, maybe it depends on the genre. If the genre of some kind of engineering, then it's very strict about flow chart. But at the other genre, for example, social science, maybe it's not too strict on flow chart.
Yeah.
Flow chart.
Because one, maybe for different field, because when I learned the flow chart is from software engineering, so actually it doesn't make strict requirement for this kind of requirements. Actually, this one is okay, but maybe for some other field, there are more strict requirements. So this is the improved one. We consider the no action that with probability PE then go here. The second minor modification is to consider the network externality for the technical support. This is the original formula for the utility. We can see this actually is the saved effort for using our technical support. But for the network externality, that means we assume if there are more people use a particular kind of technical support, then the support center can collect more information. And next time when they respond to other citizens, it will be more effective. So the new formula here, I include elements, this one, to represent the network externality effect. Here, the bit J actually is the usage percentage of using a particular type of technical support for citizen J. So for every citizen I, it will sum up all the percentage of other citizens and divided by -1. N is the number of citizens using e-government previously. So that's the second minor modification. And besides these two, the first one is, in summary, actually, the citizen can choose e-government in case of emergency, 1 out of office hour, and also we consider the network externality, try to make it more represent the real case. And also, in the original work, there is only one spot for the technical support. But I have 3 kinds of technical support, like FAQ, frequently asked questions, hotline, like call center, and email contact. So in this work, I separated into different spots, and then later they can have their individual actions for further improvement. And in the current stage, that for all the citizens, for all the social groups, the probability of using one particular kind of technical support actually is the same. But later we can change it to see how different technical support can influence the adoption rate. So based on those minor modifications, actually the result doesn't change too much. So like this figure is the original result. For citizens choosing e-government for transactional services, we can see the adoption rate actually is relatively low. But for the new model, for the improved one, actually it's still relatively low. But we can see for a particular group, the increased rate for using e-government for transactional service actually is higher here. Actually, this phenomenon may be explained by this parameter. So if this one is larger, that means the citizen have more opportunity to use the e-government. So if I run it for longer, then it will increase more obviously. So this is the minor modification. Is there any question? If there's no question for the next one, actually from the original work, we can see that for the increased technical support, the effectiveness is different for different social groups. So it's more effective for those social groups who have used e-government more frequently. So the motivation for the new work is that how we can optimize the resource allocation in terms of technical support for all social groups in order to maximize the satisfaction in terms of time and effort, the utility of utilizing e-government service across different social groups. So we want to decide that whether and how different kinds of technical support service are provided to which social groups, such that we can maximize the citizen satisfaction for all the social groups. So the purpose is this one. We try to make sure the satisfaction of using e-government of one social group cannot be improved without degrading the satisfaction of at least one of other social groups. Actually, this one is the Pareto optimal. I will talk about this later. So to formalize this motivation, I want to use the multi-objective optimization. Basically, we try to optimize multiple objectives. So this is the objective function. Actually, it's based on the utility function from previous work. And it depends on the time of using the e-government as well as the effort. And the effort depends on the static effort minus the effort saving by using technical support. This is the improved one. And here we include plus 1x. And for the time is the time for using e-government plus the time required for technical support here as well. So the purpose of this one is we try to minimize the overall utility of all the social groups for using all kinds of technical support. Here the TS is a set of technical support like T1, T2, T3. T1 may be the FAQ, T2 is the phone call service, T3 is the email. And we here for simplicity we only have two social groups, K1 or 2. So PK is the set of citizens in group K. Basically we have two sets, P1 and P2. And we require that PK is a subset of all the citizen set. And here the value of this xij, the value of this one will be 1 if citizen belongs to the social group PJ is served by technical support TI. Otherwise it will be 0. So actually this is the first objective function, this is the second one, the third one. So basically it's something. So basically this is the first objective function, and this is the second one, and this is the third one. So this is the overall utility for social group 1, this is the overall utility for social group 2, and this is the overall utility for all the citizens. So the purpose is to minimize these three simultaneously. So that's the problem formation.
Sorry. So the objective function is to minimize all the utility.
Yes, because if the utility is minimized, then they will choose the e-government.
So because the objective function is that minimize something with it should be the resource. I mean, because
Yes,
in your description is to, but limited. You should have limited resource of technical support, right?
Yes, that's right.
So
it's fixed.
yeah. So where is the fixed variable of T?
Actually, if you ask, actually this one represents the capacity of each technical support. This is in the original work, so I don't mention it here. But in the original work, we consider the capacity of each technical support. And this number is generated during the simulation.
So
Actually,
generally, multi-object optimization is to minimize or maximize something with a limited resource, or I mean, for example, cap TS equal to something very fixed one, right?
No, is
It's
like
the kind of multi-object optimization.
yeah, it's
Optimization.
like resource allocation. If you have fixed amount of resource, but you have different preference groups, then you try to minimize to satisfy the requirement of all the social groups. So you try to minimize a certain kind of utility function for all the part and try to find optimized condition. For example, actually now when I do the implementation, the function is like something like that. Actually, I have two social groups. This is the time, this is the total utility. And for group 1 is something like that. When doing the simulation, and for group 2 is something like that. So we can see at a certain point, actually, the total utility of one group is decreased, but for another group is increased. And this is the x is the time, but if we represent it in, this is the utility for A, this is the utility for B, then it's like a random dot for all these social groups. So this is the random distribution for the resource. So my purpose is that to minimize both of the social groups at the same time and try to find a pattern called Pareto optimum. So basically this solution is this X. It can be 1, it can be 0. 1 represents the resource will be allocated to the citizen. 0 means there is no technical support. So try to find a Pareto solution to minimize these 3 objective functions. So that's the purpose, the formation of this one.
Well, you can see that optimization function has three dimensions. Is that right? The TS, the P1, and P2. TS, P1, P2. So.
This one?
The three optimization function, because minimum I belong to TS, P1, TS, P2, TS, PK.
This one, right?
The last one, PK, what is PK?
PK is the total all the citizens. Here, set of citizens in group K. Actually, in this case, it's a special case. This one is not necessary if we assume the group 1 and group 2 consist all the citizens. So if we minimize this 2, then of course the overall utility is minimized. But if for further improvement, if we consider there are some citizens out of these 2 preference groups, then this one is needed. So it's optimal in this case only. But later we can increase. So So in order to find the optimal condition, we use the Pareto optimality. The definition of this one is that a solution is said to be Pareto optimal if the value of any objective function, here the objective function is this 2, cannot be improved without degrading at least one of the other objective functions. In formal language, it's like if we assume X is a solution in the solution space, F is a set of objective functions, in this case is both F1x and F2x. Then a feasible solution X is said to dominate another feasible solution Y, if and only if for all the objective functions, the Fx is not larger than Fy, and for at least one object function J, the Fjx is smaller than Fjy. This is the formal definition for Pareto optimality. And then a solution is said to be Pareto optimal if it is not dominated by any other solutions. So in diagram is like if this is F1x, this is F2x, then we have a set of feasible solutions. All the A, B, C, D, E, F, G is a set of feasible solutions. And then actually we call this one a Pareto front. That means none of the point is dominated by any other solutions. But for example, this C is not a Pareto optimal solution because it is dominated by both A and B. That means F1C is larger than F1B, and F1C is larger than F1A as well. So it's dominated by A and B. So for those points here, we can always find a dominated solution. So it's not Pareto optimality, but for this one, for this front, all these solutions lying on this line is Pareto optimal solution. So the purpose of this one is try to find a set of solutions satisfy this requirement to maximize the resulting location in terms of technical support. So, is it okay? That's the purpose and problem formation. And for the multi-objective optimization, actually in literature there are many different approaches. The original one is the weighted approach. That means we try to optimize the weighted sum of all the objectives. But the problem of this one is that the selection of the weight is quite hard. And also the Pareto solution is not unique. So how we can represent the overall solution is very hard. And the second approach is the goal programming approach, also known as the sigma constraint approach. So for this one, we try to optimize one objective while constraining the remaining objectives to be less than a target value. So for this one, how we can choose the appropriate target value is very hard. And nowadays, in current stage, the genetic algorithm, the evolutionary algorithm, is quite popular to solve this problem. And there are many different kinds of GA proposed, like VE-GA, vector evolution GA, NSGA, and then dominant sorting GA. So the next step, actually, because all of them have advantage and disadvantage, so I want to choose the most appropriate one. So next, actually, I want to do the implementation of these problems. If I choose GA to solve these multi-objective problems, basically there are 4 problems I have to solve first, like how we can represent the chromosome. But for this one, I'm thinking using binary 10101, 1 indicating serving the citizen and 0 means no technical support. And how we can define the fitness function. For the fitness function is we can use the objective function. It's like we can try to find a maximum value of this fx and try to find a minimum value as well. And then we can define the fitness function like fx minus base and half. So this one is not very hard. And the next one is how we can reproduce the next generation, how we can define the subpopulation. I'm still working on this one because there are many choices and I'm not sure which one is better. And also how we can define the crossover operation to satisfy the optimal conditions. So these 2 I'm working on. And also for the implementation, I'm thinking of using SWAS plus Java. For the GA part, I'm going to use Java, and for the other citizen actions, I will use SWAS. So, but for this one, actually I have a question. Because when I use SWAS, I found there is a class. There is a GA class.
Yeah, they are provided by one Professor Ono.
Oh, then can I use it directly?
You can use it, but there is no manual.
Yeah, but can I? But is there any description?
I think that the Ono sensei wrote the Java docs in that. So if you know that there is a library manager button in SWAS launcher,
Yeah.
and you can find the GA class library in it, and you can read the description in Java docs.
英語でしたっけ？
いや、日本語でやってたような
In Japanese.
Simple Japanese is okay. But I just want to figure out what kind of GA we use. But I can modify it a little bit.
Besides your doctoral thesis, I think you should not focus on that implementing the JGA algorithm because it takes too much time.
Yeah.
So the good ways I think use GA library in source. Maybe hacking time is small, shorter than
Yeah. I'm
designing the algorithm.
Yeah, I think it as well, because I read many papers on this one, but they all have some
You're right.
deep mathematics, and probably I don't understand it well. So I'm thinking if there is a available GA, then I can modify according to my problem formation. Then it will save much effort. So I hope I can finish it very soon.
Are there any questions? Thanks. I don't know. Did you define the equations, some equation by yourself, or are there some?
This one?
Yes, are there some differences? Did you define these equations by yourself?
This is from the original, the last paper.
That's prepared by yourself.
Last presentation.
And that's presentation.
Yes.
That's why you find by yourself.
Yes.
Are there no differences?
It's of course there is reference, but no direct reference. It's like, because for the utility function is not new in literature. There are many fields the utility function is defined.
This is popular.
Kind of popular. And then for my work, then
The theory is changed, right?
yeah, like how to say, I only use the utility function, but all the contents depends on my own problem. But the concept is not my.
Okay, thank you very much. Are there any questions?
In the sorry, I forgot the page number. Perhaps the diagram, the graph. More previous. This one. And about the possibility PE, how do you calculate?
It is not calculated. I try many different values to try to fit the situation. Actually, now it's like probably 0.1.
So if you change the value of
For this result is 0.1.
the
But
0.1,
yeah, that means if it is out of office hour, then with this probability, maybe 1,000 person citizen, there is only one person is in case of emergency, they will choose the outlet. Otherwise, if this number is too large, the simulation result is like this one. It will increase dramatically, and maybe at a certain point it will overrun the traditional counter, but I think it's not very reasonable, so try to find
and I have another question is about the network extended that you mentioned. Do you have any ideas about does the network extended exactly exist in this kind of service?
It's like some intuitive idea, like assumption. If when you use e-government, there is a support website. If there is only a small number of people using it, then the content will be very limited, right? Then probably you cannot find your own answer. Then the effort will be larger. But if more people using this kind of technical support, then the content might be richer. That means there will be more answers. Then probably when you look for the support, then you will find your answer more easily. Then the effort will be saved more effectively.
So the content you mentioned is a kind of the FAQ corner, or
FAQ is
because you said if there were more users.
FAQ is in that case like the hotline and email. I'm sure for each technical support there is a database. They collect all the customer answers. Then probably the people who respond to email or hotline, there will be some training. So if there is more content available for them, then they will respond more quickly. Then in terms of the effort, it will be much less.
So there's a kind of indirect networking extent.
It's not direct.
Exactly.
But for this one, I think for the network externality is just a concept. You can make your own assumptions to see whether the result satisfy or map your imagination or not. But for this one, actually include this one doesn't change the results too much. I just want to make it more closer to the reality.
Are there any other questions?
I mean, because this is still in early stage, so I'm not sure whether it's right or not. So if there is any comments or critics,
I think that considering the network externality, it's not so important point.
yes.
Because I think that it is easier to modify the equation
Yeah, that's right.
in future work. So
The purpose of adding this one is that because I want to optimize the resource allocation for the technical support. So now in my model, the technical support and the e-government is static. There is no operations. But later, I'm thinking of expanding the model through the organizational side. So I try to make it more active. So it's just here, just consider some situation first, and then later maybe this parameter now is random actually. Is the probability of using different kinds of technical support is still random, but later I want to use some other possibilities depends on generated from the wave simulation. So probably later this parameter will be changed in value. So at this stage is just a minor modification.
So maybe that Shan-san also Guen-san will have a 中間発表 in next maybe October or January. So in that stage, that I think the main point is the model. So maybe then, so I want you to present in next about the fixed model concept. I mean that, could you show me the diagram again? This one is not perfect, right?
Yes.
Because there is many other concepts, like for example in this today's presentation you're considering 3 types of technical support.
Yes.
And also you're now thinking about network externality. And maybe there, and I think from the one-son's comment, there's no definition of PE or that. So,
Yes.
So please make the whole image, whole diagram of your final model
final model for Shukan
Not Shukan Hapyo for the doctor degree.
uh,
I mean, you have a lot of ideas that
Yeah.
you presented that you want to use optimization. Also, you want to think about other cases. So please make the whole image.
Yeah, actually I have one overall image.
So please.
Can I say it briefly here? Because it's very short.
I don't care about that, but I think you should take several time to
Yeah.
make a brief image. Or you can use the slide, the diagram.
This one?
No, the flowchart. You can add some arrows here.
This is a little bit different from the overall picture. Now it's like still my idea is that this is the service center, the e-government with technical support, and here is the citizen interact with this service, right? And for the citizens, the diagram is this one. For the actions, but now for all the stuff maybe here, for the organization part, it's not all static. Because this one, when it talks about the time and effort, those values are fixed. So the citizen part is the initial part, but I want to go in from this direction that later expand this part, the inner operations among different departments. To provide those time and effort dynamics. So that's the kind of citizen-centered service provision. This is the whole process for the citizen-centered. And last time, Deguchi Sensei mentioned that he wants me to do this is J2C. She wants me to do J2B or J2G as well. But I'm not sure that one first, but I think there are some similarities between these two, so I want to try to finish this one first. So like now this one focus on this part. And then after I finish the optimization, this one actually kind of lying between here. And then after I finish this one, I want to expand here, like those operations here, how they influence the time and effort to make it the whole model more dynamic. That's my plan.
But if we think about the real world, the optimization process will be done by one of department.
Yeah. Yes.
So
But
maybe or staff or something. Staff maybe survey the users using, for example, using the questionnaire or something like that. Then analyze the results. Then make some implementation to the service. So think about the real world. Maybe you combine the making model process. I mean, you said that first you will make the optimization process, then make the department part, but you can combine them.
yeah.
So thinking about the department part means thinking about the optimization process. So that it means that two-stage model. First stage is now you are doing things, and the second stage representing the department part. That's all for doctoral thesis.
Why is it enough?
I think so. So if you can make the brief model of citizens part, maybe it will be the first stage, whole first stage, and
Based
maybe
on this one.
yeah.
Mm.
So that yeah, then optimization in the second stage. I think enough for doctoral thesis.
Mm. Yeah. The direction is this way, citizen-centered service provision process, something like that.
So thinking about your schedule, maybe that first of all you have to fix the citizens flowchart.
You mean try to make more improvement about this one?
Not improvement, but you have to think about the necessary concept of necessary point.
For example,
The basic part is, I think this one is fine as a basic part. And you consider the transition part, I mean that traditional government to e-government process. You added this case and think more. Are there any way? Then if you think enough, that will be the that means your goal of first stage.
maybe kind of expand this part. Try to give better definition of those
Yeah, right.
parameters.
And I think you don't think about the dynamic system. I think static point is enough to think that to judge that the model works fine or not.
Yeah, that's right.
So to do that, I forgot the definition of social group A and social group B.
Social, like male and female, there are two different social groups. Like this is according to sex and like education, like secondary education, secondary or education. This is about based on education level. And others like the age or maybe economic status. There are different ways to categorize the social groups, but they only differ in the preference of time and preference of E. They only differ in these two values. So for simplicity, in this work, I only make group 1 and group 2 to try to generalize. Later we can assign different meanings, like group 1 is male, group 2 is female, group 1 is old people, group 2 is young people. But for the optimization process, I just abstract these two. And actually same, this group only differ in preference T and preference B.
So that if you finish the first model, maybe you should analyze the more detailed results based on that kind of social groups For example, I think that the younger generation maybe use the e-government prefer to the traditional one.
Yes, yes.
Yeah, that's because that I think the older people go to the the
Yes.
traditional counter, but younger generation will use the internet. But so there is no mention about that kind of point.
In previous work.
Yeah, I know that, but there is no mention about the Europe. Here.
Just for simplicity.
Yeah, I know that. But yeah, that to
sure.
check whether the model works well or not is from the result of individual case. For example, elder people, for example, 10% of older people give up to use the traditional one, then go to the e-government. But there is no technical support, then moves to. You can think of that kind of case. So
in most kind of scenarios.
you are right. Not more scenario, but the
actions.
Yeah, result analysis.
Reality.
Then I think you can show that kind of result, and then that means that your model works well.
Okay.
And with that kind of result, you can use them in your 주간 학교.
Okay. Then I will include this one and present it in next.
Yeah, next.
In
I
next.
hope. And also please fix the flowchart.
Yeah, sure. But for the flowcharts, is there some kind of menu for strict like directions for flowchart? Because all I learned is from the papers, but the papers seems like there are many different kind of styles.
Yeah, but our base is Green-san's one. So if there is a condition, I think there is a two-way, yes case and no case. So from this chart, there is no case within office hour.
Oh, I see. So it's like
Yeah, there's no case. And also the right ones,
this one.
if that one is a condition, maybe there is no mark.
In SOAS you have with some kind of PTS, right? In SOAS with some probability, then it will do something. In fact, it has two processes. The first is generate a random number p between the 0 and 1, and then compare that random number to PTS. And if it's smaller than PTS, then the yes go to the yes process. And if it is not smaller than PTS, then it go to no process. So with something p something, then you can write this generate a random and then compare it with. It's very simple. So
I know it. I just don't know to which level I have to draw the diagram. But it is every changes to according to that step.
Could you show me the next one? So from this flowchart, there is no case in the central condition with PE.
Oh, this one?
No, that one.
Yeah.
If not satisfied PE, then what?
It's like this. According to this one, probably generate P first and then compare. If P is larger than PE, then yes.
update.
No update.
So you maybe just no goes to the top of the.
I,
Or
it,
there's a number.
no,
No, maybe the
No
no,
action.
no action to the top directory.
Yeah.
And also, for example, think about the case. The citizen chooses to use the e-government, but then it fails and thinks, oh, but
Yes.
now the office hour, maybe the citizen will go to the traditional part.
Yeah.
Now you only think about the traditional part to the e-government, but other case,
E-government.
you have to think the opposite side.
So just internet is connected.
Yeah.
So very, very strong point.
But I think the probability is very low. Think about the emergency case at 9 p.m. and 9 a.m. Oh no! Okay, I will go to that.
Sure. Maybe for individuals, yes.
I think that's all for the flowchart. Think of the left hand side to the right hand side, and also right hand side to the left hand side. And if think about the right to left, left and right, that kind of point makes your model more complex. So you don't think about that case. Only the right hand side to left hand side, and also right to left.
But
One way, maybe.
I will think how to arrange the diagram to make it more clear. Thank you very much.
Okay.
Any other questions?
Okay. Okay, thank you for presentation. Next presenter is Mr. Please prepare for your presentation.
Sorry. Where the chair?
ちょっと待って。
Should I start my presentation?
Okay.
Okay. Hello everybody. My research topic is an agent-based approach for analyzing impact of election society as public health measures. In the past, I focused on the part of the social welfare, but the social welfare is too abstract to beyond my ability to organize it well. So this time the keyword is public health measures, and election society is a part of the public health measures. This is the agenda. I will talk about the research object, background, relevant research, and research measures. The first research object. As is known to all, my research focus on the impact of vaccine supply. So the first, I'd like to
then the major relationship between the subset provision and the effector's activity. After this step, I will analyze the impact of vaccination subset on inoculation awareness. This is a part of the decision making. And finally, promotion relevant vaccine subset policies. This is a part of the scenario setting. So the first I will talk about the background. In this part, at least the flow I will talk. The first, vaccination is effective to control the infections. Although a lot of people have some questions about this part because we cannot sure that the vaccination is effective enough. But we have to admit that in the past, the vaccination is effective to some extent. Finally, vaccination rate is significantly low overall. Besides the obligation vaccination, which we must to take, actually in all of the world, the vaccination rate is low. And finally, vaccination subsidy is an important measure in public health field. Impact of different depends on different structure subsidy. I will introduce this part detailed later. The first, the vaccination is fundamental measures for fighting against the surge of infectious disease. I use a paper from 2010. The paper researched the power of the vaccination in 2009 in Washington, D.C. The yellow one shows if there is no vaccination, what will happen, and the other three lines show that depending on the different time we get the vaccination, what will happen. We can see from the chart that the vaccination was taking effect, and the effect of vaccine depends on the time to get the inoculation. We can see that from the 4 weeks before peak and 8 weeks before peak, the result is totally different. I use this chart one to show that the vaccination is effective and it can benefit us to some extent. The next, because it can benefit us to some extent, so the government set a lot of subsidy to promote the inoculation rate. Depending on the different areas, such American, Japan, or China, and they use a lot of subsidized vaccination policies. In this part, I'd like you to notice the case in Japan and the case in Hong Kong, because I will express it later. They're totally different, and we can see that in the Korea market, they provide a lot of subsidy to the old. So what is the result? The result from the 2011, we can see from the first the first chart in both in every part, Hong Kong, Tokyo, Okayama, or Kumamoto, the supply is always bigger than the consumption. That means that we waste a lot of vaccinations. This is a problem. And the other one, oh sorry, I use kanji in this part. Depending on the different age, they hold a different vaccination rate, and depending on the different part, although they are in Japan, like Tokyo, Okayama, and Kumamoto, we can see that in Kumamoto, the rate is really low, but in Tokyo it's high. And as I mentioned it before, in Okayama, they provide a lot of subsidy for the old, and it shows that the old in Okayama is really high.
Sorry? Because the consumption of in Kumamoto is bigger than the supply, so I cannot understand why the shooting is very so low.
This part, sorry, maybe I think I make some mistake because I I mean, the supply is always bigger than the consumption. I will check it later.
Yeah, maybe you
Here,
have
I
a
know it's really odd.
because
Why?
only 10 Kumamoto the sensitivity is only 5 or 10%, so maybe one digit is the
Here's
least-
maybe
yeah,
in
maybe.
because it's
That's right.
really low in Kumamoto. And why it is low? There is a question here from parents in Hong Kong because we know that Hong Kong take the subsidized CIVSS. They provide the vaccination for the children and to give some money. But the rate is also low. Why the parents don't want their children to get the vaccination? Because the parents think the price is also high though you in CIVSS. There is 62%. And parents claim the clinic nearby don't participate in the plan. This is a shortage of the plan. So next.
Professor, this data is Hong Kong in
Here.
China, but you show the data the previous one is Japan.
I also show it in China, Hong Kong here. Because I mean, I listed this chart because I want to say that this one shows there are a lot of society, and in different areas they encounter the same questions, the same problem. The problem the supply is always larger than the consumption, and the rate is low.
Okay.
So why it is low? This is the reason.
You want
Also,
to-
this is not in Japan because I cannot get the data in Japan about this part. But I think, to some extent, it can express why it is so.
You want to learn about China?
I will talk it later. This is also my confused. The problem, vaccination subsidy vary in a big way depending on the different area and the fact that without the vaccination. The vaccine subsidy should include the age, the economic status, the cost covered by the program, and the number of deaths covered, the time when the program started. And the next, how the vaccination subsidy drive the influence the vaccination market and awareness of people to get vaccination. Finally, how to control the balance between the supply and demand of vaccination. This is my research question. So in the past 3 weeks, I checked a lot of data and compare it with Hong Kong and Japan. I found that in Japan there is a difference of little chemical from the cost in every year. And they use the static data to assess the need of vaccination and set a quarter plan to plan the next year the vaccination supplement. And they cite this model by the mathematical model. A lot of people, I think, the SARS is like SPSS or R. It's a statistic program. The government analyzes the history date and predict the rate of change. Finally, set the quarter plan. But actually, the result is not good enough. It has a bug in here. And the next relevant research, it will shock me because in this month, this paper has been published. The professor Ibuka had the same interest with me, but she used the method of ordinary least square to analyze the data because she hold a lot of data. For this model, she compared the data of vaccination subsidy and the data immunization numbers. and set up correlation analysis, and finally get the result. The available subsidy has a positive impact on the community-wide healthy outcome. Because she had the same research interest with me, so what is the difference between her research and my research? Because we will use a different method. The method is using ABM to reflect the intention of each person towards vaccination society and vaccination. And I also use the influenza vaccine subsidy because we know that the vaccine, especially for the vaccination world, it is really huge. Just maybe not just, a lot of vaccination is an obligation. But for the influenza vaccination, it cannot be used for everybody. And next, I will choose a specific area to analysis. For the decision-making part, because I will use the ABM, we must consider the decision-making for the different agents. So, at the first, the government will set a series of vaccination subsidies such as the time, target group, and quota plan. If the agent belongs to the target group, the plan can affect the awareness of immunization. And depending this awareness of immunization, the agent choose whether to inoculate or not. If the agent don't inoculate the vaccination, there is an infectious disease model. I think this is familiar, especially in our life, because we set a lot of infectious disease model. And the next effect or not. In the precise infection disease model, the agent have another chance to choose whether to get the inoculation. For example, if the agent, if a lot of people get the infectious, the agent may have a high probability to get the inoculation. This has an influence on the awareness of immunization. So, my confused here to choose the specific areas because I list a lot of background in the previous slide. We can see that both in Japan and Hong Kong, they encounter the problem of vaccination distributed unevenly and set vaccination subsidy to improve the situation. And we can see that in overall, Hong Kong is extremely risk than Japan because the average rate in Hong Kong is 16%, but in Japan is 33%. That means Hong Kong needs the subsidy more than Japan, but the data in Japan is more accessible than Hong Kong. Although I check a lot of data in Hong Kong, but the data means you just can get it and you can see it, but you cannot use it, especially for the university in Japan because it's a foreigner university, not in Hong Kong, so you cannot use it.
Could you return to the previous slide?
Where is this arm?
Here?
This arm is Goki. Where is Goki?
Oh, I mean, if yes, you mean you because this is a decision-making stage. They just judge the inoculate. They choose to get inoculation or not, and yes, they choose it, and they can be dismissed from this charge.
Excluded from the petition. Get infected.
And this part is also like this one. In every steps, there with the influence on the awareness of inoculation. The agent have a chance to choose whether to get the inoculation or not.
Well, what is this is the flow chart of decision making of who?
This just judge whether to get the inoculation or not.
Of ordinary people.
Actually, for every people, because we list in the first step, the vaccination subset include the target group and the quarter plan. So, the first, if the agent belongs to the target group, or the agent can enjoy the subsidy, the agent may have a high probability to get the inoculation.
Because one flowchart can explain only decision making of only one type of agent. I mean one type of agent. For example, in this case, maybe it's people. So the vaccinating subsidy, the total quota plan and the others is belong to government side. So it's the different process. So maybe the first, if it's the flow chart of people agent, then the first maybe is the initialize the group, and then if it's in the target group, then he will the other do
I know.
the other process.
Oh,
This is the first one. Then I mean the quarter plan of how much vaccine will be generated, or how much vaccine will be produced, or something like that. That is belongs to decision making of government. Right? If the government agent belong to.
Maybe
Yeah.
you can think it from the other way. This one is a condition, and the agent, the people agent, choose how to get inoculation depending on this condition. It's not here there is some problem or some questions here. Here.
I mean,
It is not.
the way of you describe this flowchart is not. I think it's not good enough. It's because there's no way, no process from yes. Enough.
Because the decision making is just a chart whether to get the inoculation.
So, my suggestion, just my suggestion. Because the first is target. If it is if it is no, and this is yes, then it should be calculate the awareness and compare the awareness to the fixed one. And if it's yes, and he will go to your infectious usual shinko, infectious disease model. And the second one is the infection status surroundings. You have to calculate some you have to calculate some
Global.
some kind of parameters, because how the infection status of surroundings affect the decision making of patients. You have to show that. You have to show that. because just you say that infection cells of the surroundings, then what is that process? What is that condition?
Yes,
Yeah.
because in this part,
Unclear.
actually I have some ideas about this part, but it is not mature enough that I can present it here.
Okay.
Because
Also
this
the-
is also a process of decision making, and it will include a lot of parameters and include the decision make of the people surrounding the agent.
Also the influence of awareness of immunization.
Oh yeah.
It is very unclear process, no definition of that. So, for example, if you calculate the awareness and compare it to a fixed number of awareness, then it's understandable.
Yeah, I know I should express it in detail.
Okay. So when you describe some, decision making, some agencies should be very clear and because it's in the model, the model should be described in detail, clearly.
Because the idea is not mature enough, and I encountered a serious problem is a causal hapio. So, I mean, for the causal hapio, my research maybe talk about this part and how detailed this part would be. I'm not sure. Maybe I can show the idea, but because idea is not mature enough, so I'm afraid.
So there's a lot of there's a lot of ways, methods to, describe your conception, research concept. So maybe not flowchart. Flowchart is you can use figures, graph figures, because concept. This is a conception. The abstract one. No need to go to the detail.
Actually, it is a totally different ideas depending on the different people. And Professor Deguchi think the flowchart is better than the graph. So.
But this flowchart is not. We cannot understand it.
Yeah.
Flowchart.
Vaccinated people, vaccinated people never infected in this season.
Infected people.
Vaccinated people
cannot
never
get
infect in this.
Actually, this is also the confusion I encountered because I mean in this part to join the decision making in this part I may use the probability if the people don't get the inoculation whether the people can get the disease or not. And actually, in the previous model, if the people get inoculation, he will never get the disease. That means vaccination is powerful enough. But actually, this is not reality.
What is your research purpose on your research? I know. I think your research purpose is to estimate, to know the effect of the vaccine subsidy.
Yeah.
Are there need for considering the infection stage? If you want to know the subsidy's effect, you should consider more the decision making of go to subsidy, go to vaccine.
And I was simply to say that what I want to do is the connection between the vaccination subsidy and the influence on the awareness of emulation.
Yeah, is it your papa?
Yeah.
Your research papa?
Because I show this part, we can see that in the x-axis, it shows the price of vaccination and the y is the immune liberation rate. My research purpose is to research the relationship between the price of vaccination and the immunization rate, because the price of vaccination, maybe not just the price of the subsidy, overall, it can affect the immunization rate and affect the awareness of inoculation. My research focuses on the relationship between them.
Your purpose is this point, if so that
Yeah.
the diagram is I think it's not meaning it's not meaningless, because this diagram is the process of infected process, but this is only a process of infect, but you want to research about the effect of such points. Such points, maybe 日本語なんですけど、もしかしたんですけど、調べたいっていうを考えると、どちらかというと感染する過程じゃなくて、こういった経済状況とかそういったものが影響するところが意思決定に関わるようなところをメインにダイアグラムとしてで感染するというのは既存のやつを使う程度でいいんじゃないかな。
この辺なんか例えばこの辺全員 target group, all of the target group gets inoculation. No doubt that the infection disease rate will decrease. Right. So it has some influence on this part.
関さんのその目的がなんかみんなにもしかしたら伝わってないかもしれないので、日本語でも言ってもらっていいですか。
このワクチンの政策と、実際の感染率の影響。
それをこうエージェントベースでやるっていうのは、なんか普通に統計から出すような研究。
そっちの方がいろいろまとめていく。
なんかエージェントベースで下からやる感じ。
今
データが足りねえよ。
エージェントベースないですね。
だから
これじゃない。統計って人間の意思決定とかないですね。だから実際に統計データからの分析なんかずれてますね。
変わってるじゃん。10%しかずれてる。
確かにそうかね。
だからいい方法ですか。
いいか悪いかはどの規模のデータが
これが十分じゃないかと思っちゃうんです。
目的に合ったダイアグラムとはちょっと思えないかな。
まあダイアグラムはまあいいんじゃないかな。それはなんかそんなにみたいにしようか。
エージェントベースでしたらなんか関東分析ぐらい意味があるし。
最終的にインフルエンザとかの感染を分析したいなら、まずそのサブシディをどれだけ受け取るかみたいなサブシディのモデルをなんか考えて、そこには別にインフェクションとか入れなくて、その後にそのもらった結果なんかインフェクションがこう変わるかみたいな。なんかインフェクションが途中で入るとなんか
そうすると人間の意識はどこに見えますか。
それをそのコストを使って変えていく
なんか今の
コス
問題は
トとかで受ける人が変わる。
なんか数学 モデルとエージェントベースモデルのそれなんかどっちがいいか悪いかこの問題についてどっちがいい
てかあれじゃないなんかむしろ問題意識がなんかちょっと不足してるんじゃないか。エージェントモデルやるのかエージェントベースやるのかよりも先に何をやるのかを考えた方がいいんじゃないか。
何がしたいの？
この2つの関係を例えば
Price of
どんな
blockchain
ポリス例えばどんな政策を作って人間の意識をどんな影響があるかこれを研究して
政策。So, okay. If you think your model as a system, the system has the input and output. What's the input of your system?
the time target group and quarter part. We set the price.
That point is the component of the system. What's the input?
You know the first one? Maybe the first to show that it's the city and they have infections. So it's subsidy and subsidy to
Influence.
of effect どんな影響があるか
Kind of influence.
For example, if all the vaccines break,
So that the input is the scenario of the subsidy.
Yeah.
And then output.
The infection rate, immunization rate. Actually, there is a prop from the causal law, so they say that if there is no option, this will yes, the time and the people get infections. And but if there is but if we have a vaccination, the graph will be this time. And in addition, if we have a proper society, this will be
Proper.
a good society.
つに分けてるって感じです。感染のプロセスと補助金はどうやって効くかっていうのが、感染率が下がっているのはその接種する人が多いからですよ。でなぜ接種する人が多くなるのは安くなっていたんです。
Are there any regulations to the system?
Because we know that the initial subsidy has the target group, and especially I show this one. You know that near Wakayama, their target group is the old, so the old have a high immunization rate.
じゃあ他の都市の値段とかのデータを元にして東京とかでどのぐらいの値段になったらどのぐらいの感染者数に変わるんじゃないかみたいなシナリオ分析はしませんか？他の都市のワクチンとか接種の値段となんか感染のところは厳密なそういう数理モデルとかそういうなんか理学系の話になってくるから俺はエージェントベースは向いてないんじゃないかと思います。むしろこういうなんていうか値段とかとその人の動きの影響とかはなんかエージェントベースにもできるような気がするんですけど。
サジェッション。例えば生産のシステムはこういうシステムを作りたくて、インプットはサイズ、時間いつみんなに交付する、いつ、ワクチンを交付するかとか、どれぐらい交付するかによってこのシティの例えばインシェスカーどれだけ感染者がどれだけいたかというこれの変動を調べたいですね。こういうシステムを作りたい。これが、僕は学部の研究の時は SIR モデル作ってて、例えば2週間感染者がどれぐらいが、どれぐらい発見されたらワクチンを投資して、それによってその SIR カーブがどういうふうに変動したっていうのをここ SIR モードを作って調べたり、これはとても簡単ですぐできちゃう。だけどそもそもこれが数理モデルでも解ける問題なので、もしセツさんはエージェントベースで調べたい、そしてワクチンのお値段とかはどういうふうに人の意思決定に影響するかっていうのを調べたいんだったら、それはエージェントベースを使う、エージェントベースモデルを使う余地はあるんですけど、ただこれを調べたかったら、エージェントベース作ってもいいんだけど、そもそも 意味は何なのかっていう、まあ、要は制作に絡めたいんだったらいつどれぐらい時間いつどれぐらいとお値段どれぐらいお値段でそれを全体の例えば感染者の数にどういうふうに影響するっていう調べたいんだったらもっとこう例えばその家庭の家計に関係するようなプロセスを考えないとなんかエージェントベースでモデルでやる必要がないんじゃないかっていう。あと例えばこのシステムで作りたくてこのシステムはどういう要素があって、CD の構造家族の構造とか人の意思決定はどうなるかっていうそれまずディフィネーションモデル作ってなくてもディフィニッションが必要ですのでさっきのフローチャートだと誰かのディシジョンメイキングか分かんないしシステム全体の要素は分からないのでまずイメージとしてこういうどういうシステムを作りたいという構想発表では聞かれる、求められる、内容なのですね。バックグラウンドはもうさっとでいいのでそのコンセプションモデルのコンセプション何がいること何がその中でどんなプロセスがあるかというのを説明できれば構想発表会乗り越えれると思うですよね。
いやーそうなんだけどさコンフューズしてるのはただ単にフローチャートがいけないだけであれをちゃんときれいに書けばエージェントベースでやる理由は分かるんだけどそもそもね意思決定の部分最初のさコンディションの部分がおかしくてThis flowchart has two concepts. One is the awareness of the subsidy and also the concept of the infection state transition model. So to combine both of these, think about the real world. The first condition is maybe that infected or not. Think about the real world. And in this, in your model, if the point is infected or not, or vaccination or not. Point. So, if this case,
Yeah,
right.
No
Right.
need to get in the
daily activity. Maybe that maybe there is some isolation policy or go to the hotel. That kind of things is included here. Maybe that infected daily activity. Okay, so the no case.
infectious mode here.
脳の場合はdecide whether to get poison or not. So no case daily activity. Yes.
This one in order to choose the unique condition. で、ここにインフェクションプロセスが入ってるといいだけでしょう。これ分けちゃダメです。もう感染モデルなんだからデイリーアクティビティの中に感染のモデルが入ってるんだから、まあちょっと挟むんだったらここにインフェクションプロセス入れる。そうするとだからこの辺っていうのがエージェントの内部プロセスになってくるでしょ。これがA パターン、B パターン、C パターンが影響してくるでしょ。で、この部分がインプットの部分でしょ。で、出てくるのはここからアウトプット取るでしょ。感染率列まだね。
その ABC は多分セッサンがやりたいの
そう。
はインフルエンザ、awareness or infected surroundings 要は周りに影響しやすい人が A パターンとか、あと意識の高い人たちが B パターンとか C パターンとかそういう感じだ。
ABC はあれだよ、お金いくら配るかで、その先にその先にあるエージェントの丸の中で、内部モデルで、アウェアネスオブイミゼーションが入っている。基本的にコンディションの部分が設計する部分だから、それをエージェントで作んないと。で、リアルタイムの時系列に合わせてフローチャート書かないとおかしなことが起きちゃう。制作受ける受けないの話が先にあるから。
でも感染してたら、
感染してたら別にワクチンとかどうでもいい。
いいですかね、感染しててワクチン受けてねみたいなんてないですか。
ないな。だってワクチンってインフルエンザの卵を産むやつだから、感染してたらもう打っても無駄だもん。
あ、まあその時のことってことですか。いや、俺だったら感染したら、あ、いやその
感染し
一期ってことだからいいんですか。
そうインフルエンザ感染したらもう抗体できちゃうから。
あ
あるのは A を受けた後に B 型取るっていう最悪なパターンはあるけど、
あ、一回かかったらもう
1回かかったらその期は6ヶ月だっけな、確かインフルエンザは効果が。
具体的な地域によってワクチン作る時間とか違います。
地域って国？
例えば日本で、12歳未満の子供は1年間2回ワクチンを受けるルールがあります。
1年間じゃなくて一気にでしょ。季節に2回でしょ。
そんな重要じゃなくね。
日本はいつも10月から
そうだよ。で10月と11月に1回ずつ打つでしょ。
でも他の例えば香港は1回だけで大丈夫。
あ、それだから、2回打つとただ単に抗体性が上がるだけで別に1回でもいいんだよ。だけど子供はさ、外部に対してパワーがあるからこううまく卵を付着しないことがあるから2回打つ。別になんか大人2回打ってもいいんだよ。
この厚生労働省のデータもあります。この1回と2回の結果が違います。この比べる部分もあります。
いや、それはそうだよ。2回打った方がパーフェクトだもん。年じゃないよ。6月と12月に打つってわけじゃないよ。
10月から12月まで2回。
じゃああれです、これを受けたかによってそこのインフェクションプロセスって中身が違うからどうですか。
予防接種は1回でいいんだよ、基本で。打った後に1ヶ月かかるの、ワクチンができるまで、体の中に。でワクチンできた後にもう1回打つと反応するわけよ。ワクチンってインフルエンザの菌入れることだから、だから子供を2回突っ込めば抗体価が上がるでしょ。1回目が甘いと。大人の場合はもともとさ体力あるから抗体価高いから1回でいいわけで、大人2回打つと完璧になるんだけど、俺とか2回打ってんだけどさ、病院によっては2回打たせるよ、大人にも。大人は1回でいいって言われてて、子供は2回っていうのはそこなの。だから別に年に2回打つわけじゃないから、シーズンで2本打ってパーフェクトなものを求めてるだけだから、それが厚生労働省の指針なの。子供は2回打ちましょうと、かからないように。ただだから国によっては1回でいいよって言ってる国はあるよ、ちゃんと。子供でも1回でいいと。そういうこと言ったんだっけ。外部はグエンさんが書いたものでしょ。で内部があっちでしょ、フローチャート。終わり。
じゃああれですか、これがその対象とするエージェントが子供の場合とか大人の場合によってここの中のその
まあだから最初そのあれでしょ、接種したかしてないかのプロセスで子供の時だけ2回かどうかの条件分岐がちょっと変わるだけでしょ。
ああ、で2回やったらもっとかかりにくくなるみたいにすればいいんですよね。
でもさ、結局それはエージェントの中の抗体価の話だから、SIR みたいにトップダウンの感染率じゃない設計をしていればいいわけですよ。だって人によってさ感染率は違うはずなんだ、元のこと言ったら。派生版はあんまり条件分岐のところで変えればいいだけだから。
Immunization awareness。これは内部、人の内部のデータとは
大人がクラッシュミラーを作りたい。人間のもともとはどんな意識 でも確かにこの接触するかどうか人間によって違いますね。
クエスチョンでトークを
何パーセントか分かる？それ100人に配ったら何人返してくれるか。
大体この前の香港のデータみたいな感じ。
だから100人に聞いたら何人答えてくれると思うって。
半分くらい。
全然いかないですよね。5人に答えればいいこれ。
5人
5% だよ。5% いけばいいアンケートだよ。
じゃあせめて1万ぐらい。
1万集めて100だね。100から200じゃない、多分 3% が平均だから大体。そうなんだよ、アンケートって。
謝礼とか
で、じゃあ上げたければ関心の高い人に聞けばいいんだけど、それじゃ偏るでしょ。
そう
ランダムに選んだ人が回答しないとダメだから。クエスチョンオンエアは難しいんで。あと誰に聞くのかもあるし、どうやって選ぶのかもあるし。
なんかできれば年齢層によってそれぞれ。
いや別にいいんだけど、だからどうやって聞くの？
年齢わからない。
年齢聞くの？アンケートの中で。
そう。
で、どこに配るの？
例えば子供がこの撮影を受ける可能性があります。
どうやって探すのその人たちを？
子供の考えはなんか具体的に地域を選択して、地域の中のなんか、まず友達から最初は香港のデータを取りたい。
いいよ、香港でもどこでもいいんだよ。
だから香港の友達と約束してなんかあっちがアンケート調査とかやってもらう。
だからそのアンケートする対象がランダム性があるならいいよ別に。
駅の周辺。
駅の周辺とかじゃダメでしょ、こういうのって。しかもアンケートって人じゃないでしょ、これ家庭に配んないと。個人じゃ無理だよ、家庭に配らないと。大島のアンケートの時は家庭に配ったんだもん。そう、子供が対象にするんだったらどこに配ればいいと思う？簡単だよ。そうそう、学校で、学校が配らせてくれるかどうかは知らない。そもそも日本の人が学校に来てアンケート取れて日本の研究機関でやっていいかなんてそんな多分出ないよ。だからこの間メールにもしたけど、アンケートは向いてないって、こういう病院の連携取り付けないと。そうすると実際のデータから自分で推計するしかない。
この前調べたんですけど、このアンケートは埼玉県もともとするアンケートがあります。
あるよ。
なんか埼玉何々保険医療何々、こういうアンケートがあります。推奨するかどうか。
じゃあさ、
政策を受けるかどうか。
そしたらさ、コレクトデータじゃなくてさ、エスティメイトデータでいいんじゃないですか。僕とかはそうだよ。もう個人情報取れないから、公開されてる情報から自分で計算するんだよ。こうじゃないのかなって。
こんなデータがあれば、使っていい。
ここでそれてんだったら使っていいんじゃない？
使った方が楽だよね。
質問とかあれば時間もないので終わりでいいですか？
ありがとうございます。
ゃんさ、アイディア考えるときにさ、やりたいことの方にさ頭が行きがちだからさ、そこちょっと気をつけてごらん。フォーカスしすぎるところがあるから研究するとき
3分ぐらいから始めるので
もっとね広く見ないと。もうこれって決めたらそればっかやっちゃうから。
あ、まだ後で言うので。
あ、でもまだ大丈夫です。
Good afternoon.
トラベルの立て替えが大丈
Now I start my progress report.
いつより
In previous progress reports, I was thinking about optimal management of the spread of car sharing. But in this time, I think about environment and energy problem and solution like next generation automobiles and new mobility systems. New mobility system is also car sharing is also one of the solutions of new mobility system. What is next generation automobile? Next generation automobile stands for lower gas emission car. For example, electric vehicle or hybrid cars and so on. And a future car has sensor which can future car has sensor and exchange data by IT technology and the car can get data on the way drive, and by the data we can know some information. Future car. And today's I outline what I have done, and second what I'm thinking about, and three questions. I read Mr. Sasaki's thesis. Mr. Sasaki is belonged to Kijima Lab, and he researched car sharing. And his thesis point of view is sustainable society. Sustainable society stands for developing and care for environment. Also think. And to sustainable society, he researched how much influence the spreading of car sharing has by source. And I think to consider purpose the method is crucial point. The previous progress reports, I think car sharing system, but it is important for sustainable society.
what can I do? And I went 未来社会シンポジウム、モビリティが作り出す未来シンポジウム held in Akihabara in June 30th. And in this symposium, many companies related car appeared their new technology and vision about the car. And my most interesting thing is car connected in network. For example, if cars have sensors which can know weather, by intercommunicating with data center, we can know moving of clouds in very local point.
The effect of the cloud moving in your car.
Weather.
Thank you. これはウェザーでしょ。
あ、
ウェザーですね。
こういう面白いことができますよっていう例です。車が例えばセンサーを持っていて、なんかこう IT の技術とこう車っていうのを結びつけたら何か面白いことができますよ。So I'm thinking about if car has sensor and exchange data with data center and communicates with other car, we can something for environment and energy problem. So if you have any good ideas, please tell me.
Yeah, I have a question. So, your original interest is about the market of car sharing, and as you mentioned that recently the cars get connected with a kind of cloud network, and many uses could be developed, and perhaps you can consider, since the car has been connected to the network, and this kind of innovation may have some influence with the service of the car sharing, or some new service of car sharing industry can be developed at the background of this kind of new innovation.もともとカーシェアリングっていうのが、ネットにつながっていないんですよね。で、つながった時点で何か新しいサービス提供できるか、カーシェアリングだけができるみたいなのがありますかっていうのは考えるのもありかなと思います。
目的は一緒ですか？カーシェアリング
そのカーシェアリングを増やしても別にそんなに嬉しいことはないなっていうのを前指摘された通りだし、なんか佐々木さんの論文でも述べられてたで、ここの佐々木さんの論文の結果なんですけど、別にカーシェアリングを増やしたところで環境への負荷は実はそんなに変わらないんじゃないかみたいなことも述べられてて、
交通とか交通使わされた
ここら辺はなんか
別にカーシェアリングこだわらなくても大丈夫みたいな。
そうです。その環境問題とかの解決策の一つとしてカーシェアリングっていうのを考えたんですけど、カーシェアリング自体の効果っていうか、前も指摘されたようにその日本の社会には合わないんじゃないかみたいなことも言われまして、でそれならもうちょっとなんか新しい IT とか最近こう車の業界でも言われていて、何か新しいことができないだろうかっていうことを考えています。
例えばなんか渋滞が発生したら、なんか環境に悪いんじゃないですか、いろいろ無駄になっていて、そのネットワークにつながっていろいろなんかリアルタイムのデータが取れるじゃないですか。でそのデータに基づいてどこら辺は渋滞に発生になりそうなのが予測というか、まあ、考えてその今走っている車みんなにこの辺はちょっとやばいのでできるだけ避けた方がいいというアドバイスして、こういうアドバイスによってみんなのそのなんか運転手の意思決定が変わってくる、みたいな。
それをなんか IBM とかが
作って
ストックホルムかなんかでこういう話を
みたいな話です。
まあそれは多分環境とか排除しなくて、多分渋滞だけでもやれるからね。多分やってんだよね。
でもまあそれは全然手法の問題で、
ADM ではないだろう。
じゃあ普通に実証実験ですか。
英語だけこうそういう技術みたいなのを作りたいってこと。
作りたいっていうか、作れる、実際に今の技術だったらこうできると思うので、こういうのをしたらいいんじゃないかみたいな提案ができたら、
そのデータの自分の提案のなんかそういう定量的な検証もするっていう。なるほど。まだ具体的なアイデアはないみたいな。プレゼンとしては以上です。
以上です。
とりあえずさ、アイディア人に聞いちゃダメだよ。人に聞いたらその人の研究、自分の研究じゃなくなっちゃうの。自分で問題提起をして自分でここで発表してコメントをもらうならいいけどさ、何にもない状態で何かありますかって聞かれたってそれは研究じゃないですからね。それとカーシェアリングビジネスは別にいいんじゃないんですかね、やってもって私は思うんですけど、
金銭的な面では僕があるっていう話です。
そうで多分考えてないだけだと思うんだけど、言い方悪いけど、例えば、まあ、皆さん豊洲地区とか行ったことある人は分かると思うんですけど、あそこ、マンションだらけですよね。あんな高層住宅に何百人って入ってるところで駐車場確保しようとするとどうなるか分かりますよね。しかも土地が高いところでしょ。例えばゼネコンとかが考えるんであれば、高層マンションで駐車場の数を減らせればそれだけコストダウンなはずなわけよ。で入ってる人のへのサービスとしてカーシェアリングがちゃんと働くんであればこれ以上のメリットはないでしょ、っていうビジネス展開が考えられるのよ。そこまで考えなきゃカーシェアリング、そういう意味も込めてカーシェアリング全体で見ても面白くないよって話をしたのに、日本全体で考えたらそんな流行るわけないんだよ。でヨーロッパの事例とか全部調べたんでしょ。カーシェアリングが流行ってるのってどこよ、都心部でしょ。なんで都心部カーシェアリングが流行るの、駐車場がないからでしょ。 ってとこから日本の事例を行きつければさ、高層マンションとかいっぱい増えてんだから、あの辺でさカーシェアリングの一体化サービスした時に住民の満足度と提供する側のサービスとのコストの割合でウィンウィンが出るんだったらいいんじゃないですか。でエージェントベースでやる必要がいっぱいありますよね。だって中のマンションの世帯構成に応じて利用時間帯とかも全部変わってくるわけだから、その時に車を何台入れた時にどう回るかとかね、人によってあるわけでしょ。30分だったら妥協できると、回すのぐらいだったら、次空いてるのが30分後1時間後ですって言ったら妥協できると。逆に全然妥協できない人は駐車場借りればいいと、車買って、その辺でコストの面とか全部計算かければエージェントベースでやる意味はいっぱいあるんじゃないですかね。だから全体的な考え方よりも局所的な考え方をしてあげた方がいいわけで、さらに環境面の配慮でいくと、佐々木君みたいに全体で考えたらそれは伸びるわけないんだよ。マンションとかの土地全体、東工大の中だけで削減できるんだったらそれはそれでいいじゃないですか。環境配慮もしてるんだから。それが今度出てくるマンションが全てそういうことを考えたら削減率なんて結構なものになるでしょっていうところを考えてやればいいんだよ。いっぱい出てくるよアイディアなんて。さあ、ねぎ直したね。でちなみにこれの話でいくと、いや IT につなげたからどうなのっていうのと、電気自動車が出てきたからどうなのと思ってしまう。達成の可能性がこの2年の話じゃないから、多分やっても面白くないと思うし、空想の世界で終わってしまうと思う。現実的に困ってないし。いやでもっと言ってしまうと、多分変な話だけども、カーナビにアンドロイド載せればいいだけの話でしょ。アンドロイドか iOS か WindowsOS か知らないけど。なのでもうちょっとカーシェアリングめげずにやってほしかったな。ネタはいっぱいありますよ。特に言ってしまう、アイディアをばらすのあれだけど、さこれから日本しか考えてないでしょ。よく考えてみなよ。これから日本自動車大国になる国がいっぱいあるんだよ。これから高層マンションを建てて都市近代化しようとしている国がいっぱいあるわけじゃん。それの先行事例で日本でかければさ、ね、どこどこ工務店さんとかは助かってしまうよね。そうだからヨーロッパの事例からなんで成功しているのかを導いた上で日本で当て込んだ時にこんなこと提供できないかなって考えればカーシェアリングでいくんじゃない？
ありました。
甘いよまだ。嫌な汗がめっちゃ出るぐらい考え込まないと。やべえ、この研究やっても意味がねえんじゃねえか、本当に意味ねえなって思ったら変えていいよ。
Is there any other out there?